Okay, take two. I did this once and it didn't work. Very annoying. Okay, question number 11. This is January 2004. Question number 11 wants the domain. Remember, all you have to do is note that what is inside has to be greater than 0. A division by a negative will flip the sign around, so the correct answer is option A. And 65% of the population figured that out. Question number 12 is using the log rules. So you can pop the 3 back up into the exponent position. Then the subtraction means the A will be on the top, B cubed on the bottom. The C will mean that the C will be in the numerator. Correct answer is B. 68% of the population figured that out. Question number 13, you have to know that an exponential and a log function with the same base are inverses of each other. So 2, 9, swap it around. Correct answer was 9, 2. 67% of the population figured that out. Now, number 14 is one that only 39% of the population got correct. So what caught a lot of people? Well, it's a subtraction, so I'm rewriting it as a division. Now there's logs base 2 on both sides, so I'm going to be able to ignore the logs and do a little cross multiply. So when I solve, it's a nice easy equation. I get that x is equal to 3, making this a very tempting wrong answer. If you go back and check, 3 minus 6, that's a negative. 3 needs to be rejected. D is the correct solution. Question number 15 is solving an exponential equation, and you can make the bases match. A 9 is a 3 squared, and on the right-hand side, you have a multiplication of powers with the same base, so you're going to add them. That's 2x plus 4 is equal to 4x plus 2. Solve that equation, you'll get a 1. Question number 16 is a log equation where the bases don't match. Doesn't matter. Log base 2 of 8, that's a 3. Log base 3 of 1/3, that's a negative 1. So it turns out that this was just a logs on one side equation. We solve it with a kick bump, you get a 16. We are on to question number 18. Question number 18, 96% of the population figured out the correct answer was A. Question number 19, Sanjam asked me, if I'm going to do synthetic division, do I have to write out all the powers from 39 all the way down? You would, so don't do it that way. Use the remainder theorem. If you plug 1 into the polynomial, you're going to get the remainder way faster. The remainder is found in A. Question number 20, same thing. There's an x value, there's a y value. So substitute the x value into the equation. Make it equal to negative 5. You've got an equation to solve, and you'll get a k value of negative 2. Question 21 wanted all the roots of this equation. What makes this 0? Plus or minus 2. What makes this 0? Nothing. What makes this 0? 5. The correct answer is B. Question number 22 wants us to solve this polynomial. So I'm going to start with my try numbers. They're positive and negative 1, 2, and 3. 1, 2, 3, and 6. Here's the little tip. Look, all of the answers either have a 1 or a negative 1, so start with that. 1 works. So I put 1 outside my synthetic division box, and I begin my process of multiplying and adding. I'm left with a polynomial that factors quite nicely. It factors to an x minus 3 and an x plus 2. So in addition to the positive 1, I also have a 3 and a negative 2, which makes the correct answer option D. And the last non-calculator question is number 30. A few of you asked me about this guy today. It says a square piece of cardboard 10 centimeters by 10 centimeters will have equal sides of length x cut off. which means your new length is 10 minus 2x, your new width is 10 minus 2x. It wants an expression for the volume. Length times width times height. You don't need to expand that.